So far, our C++ programs consisted of a sequence of C++ statements all put inside the main function. Here is an example. So if you've got the main function, we have a sequence of statements, statement 1 up until statement n. We know that the program execution starts with statement 1 at the top and moves all the way to the end until statement n. And then, the program terminates basically. This problem with this style of programming is the following. If the same sequence of statements is needed at different locations in the program, that code snippet must be copy-pasted, which results in code duplication. Let's look at an example. Assume that you would like to print the following pattern on the screen. We have a 3 by 3 triangle, then we have 3 by 3 square, and then these patterns are repeated one after the other. The easiest way to implement this is to write a main function like this. So we have three printf statements to print the first pattern, triangle pattern, then another three printf statements to print the square pattern. Then we basically replicate or duplicate the code. We copy and paste the code that prints the triangle pattern, and then we also duplicate the code that prints the square pattern. As you can see, we have to do copy and paste. You may say that, okay, I can put this into a loop, that executes these statements twice. But as you assume that there are some other statements in between the, printing these patterns, that it is not possible to, put these inside of a loop. So the whole point we are trying to make is the following. Anytime I would like to print this pattern, the triangle pattern or the square pattern inside of my main function, I need to copy and paste this code. There is no way around this problem. So let's go to example 1 first. Here's example 1. Like I said, I have three printf statements to print the triangle, three printf statements to print the square. And let's say I want to print the triangle pattern again, then I have to do a copy and paste. The square pattern, I have to do a copy and paste. Let's say I want to, print another triangle pattern. I have to, copy and paste it again. So let me copy and paste and copy and paste. Bottom line is, anytime I would like to print one of these patterns, I have to copy the code and paste it again inside of my main function to get the job done, which results in a duplication of the code. So here it is. You're basically saying print the triangle, print the square, then print the triangle, print the square, and then print the triangle twice, right? So bottom line, this results in a lot of code duplication, which is not something you would really. When we do code duplication, what we are violating is the famous software engineering principle called DRY, or do not repeat yourself. So you can find the Wikipedia page in here and read more about it. The DRY principle basically states the following. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. This principle has been formulated by Andy Hunt and Dave Thomas in their book, The Pragmatic Programmer. And the moral of the story is the following. Anytime you do copy and paste the same sequence of statements into different parts of your application, basically you are duplicating the code or replicating it, you are violating the DRY principle. And this is something you should be aware of. You should never, at least you should try to never copy and paste code within your program. To solve the problem of code duplication, the concept of a procedure, subroutine, or function has been introduced into programming languages. These three terms, the procedure, subroutine, or function, are used interchangeably. So they all mean the same thing. So different programming languages might be using different terminology, but they all mean the same thing. It's basically, the idea is to extract the sequence of statements that perform a specific task and put them together into a single place and give it a name. For example, you would like to print values on the screen. That's the job of our printf function. Or compute the minimum or the maximum of two values. These are the minimum and maximum functions. Or compute the square root of a number. That's a square root function. Or print a triangle pattern that we just had, or a rectangle pattern, or a square pattern. So each of these is a specific task. Going back to our example, we have two specific tasks to perform. One task is to print out the triangle pattern. So what I will do is I will pick up the code that prints the triangle pattern and put it into a function and give it the name triangle3. And another task to print out the square pattern. So I'm going to pick up the part of the code snippet that prints out that the square pattern and put it into a function called square3. Because I'm printing two triangles and two squares, what I'm going to do is now in the main function, I'm just going to call these functions. So I'm just going to say triangle3 to print out the first triangular pattern, then call square3 to print out the first square pattern, then call triangle3 again to print out the same triangular pattern on the screen, and finally call square3 again to print out the 3 by 3 square on the screen. To execute a function call is made. This is sometimes called function invocation or function call. So within the main function, we are invoking triangle3, the function triangle3. So when we do this, the control is going to jump to the first statement of triangle3 function. So the control is going to come here. We're going to execute everything inside triangle3. When we reach the end of the triangle3 function, the control is going to come back to the colors scope, which is main, and continue with the next statement in there, which is square3, which is a function called to square3. So let's now, trace this through. So we are here at the beginning. You're making a call to triangle3. So the control is going to jump to the first statement of triangle3 function, going to execute the first printf, then the second printf, then the third printf. As you can see, we have now printed out our triangle pattern on the screen. When we reach the end of triangle3, the control is going to come back to the colors scope. Remember, we are calling triangle3 from the scope of main function. So we'll be coming back to main and continue with the next statement after triangle3 call. This time we are making a call to square3 to print the square pattern on the screen. So the control is going to jump to the first statement of square3 function, and we are going to execute the statements inside square3, and that's going to print the square pattern on the screen. When we reach the end of square3, again the control is going to come back to the colors context and continue with the next statement, which is return 0. And when we execute return 0, the program is going to terminate. Let's now look at example 3.cpp, the actual code. We have two functions, triangle3 and square3. And we are calling those functions from within main. So the first statement of main is a function called to triangle3. Then the next statement is a function called to square3. I put a breakpoint in here. I'm going to go step by step. So let me go into the debug mode so that the control stops at the first statement of main. Then, as you can see at the top, you see the debug controls. There is step into and step over. If you do step over, it just executes the function, but I would like to do step over, F11 to go into the function. So I'm going to do F11. We are now at the first statement of triangle3. So let's execute the statements of triangle3. And to print the triangle on the screen. When we reach the end of triangle3, the control is going to come back to main, to the next statement after the call to triangle3, which is a call to square3. Again, I'm going to do F11 to go into square3 function and print the square. And when we reach the end of square3, the control comes back to main. And when I execute that, the control terminates the application. Let's now formally define what a function is. A function is a named sequence of statements that perform a specific task. Let's look at some examples. Printf function, its job is to print a message on the screen. GetLine function reads one line of input from the keyboard. The maximum function computes the maximum of two values. Square root function computes the square root of a given number. Triangle3 function we just implemented prints a triangle of size 3 using the star characters. And square3 function that we just implemented prints a square on the screen of size 3 using plus characters. And you could think of a lot of other functions out. Every function that you define in C++ must have a function header, sometimes called a prototype, signature, or title line, and a compound statement that comprises the function body. Here's an example. The function header must have a return type, a function name. This is a name that you give to the function, and a set of parameters inside the parentheses. If the function does not have any parameters, then the parameters is totally empty, but you still have to have the open parentheses and close parentheses. The function body is a compound statement, meaning that you have to have a open curly brace and a closed curly brace, and all the statements that make up the body of the function has to go in between these open and closed curly braces. At the end, if the function is returning something, you have a return statement and an expression to return a value from the function. Not every function has to have a return value, but if they do, this is how you return something from a function. That's why here's an in-depth look at the function prototype or signature. It must start with a return type. So in this example, the function is returning an integer, followed by the function name, which is add 3 integers in this example. You should give descriptive names that reveal what the function is doing. Apparently, this function is supposed to add the 3 integers that are passed as parameters. Finally, you've got an optional list of parameters that follow the name of the function. The parameters are symbols that represent the information being passed to the function from part of the program calling the function. So part of the program that's making a call to this function is called the caller. And when you make a call to the function being called is called the callee. All right, or the function being called. So in this example, the function has 3 parameters, A, B, and C. You have to declare the type of the variable. C++ is a strongly typed programming language, so every parameter, the type of every parameter has to be declared. In this example, we've got 3 integers, A, B, and C, so we say integer A, integer B, integer C. And if you have more than 1 parameters, as in this example, you have to separate the parameters with a comma, right? Integer A, comma, integer B, comma, integer C. We don't put a comma at the end of C because there are no more parameters that follow C. C is the last parameter. All right, so you only have comma separating the first and the second after the first and the second parameters, but not the third one, because third one is the last parameter. Let's now look at some example function prototypes. In the first example, we've got a function that has no parameters and returns nothing. When the function returns nothing, the return type is void. So you say void f1, this is the name of the function, and it does not have any parameters. You can either put void in here or leave it completely empty. So you could just say f1, open parentheses, close parentheses, or you can even put void in there. The compiler doesn't care. The second example is a function that has 1 integer parameter and returns nothing. So the return value is void. The name of the function is f2, and it takes 1 parameter, integer a. The third example is a function that has no parameters and returns an integer. So the return type is integer, the name of the function is f3, and it doesn't take any parameters. You wouldn't typically write void if the function doesn't take any parameters. You would simply say open parentheses, close parentheses. And the fourth example is a function that has 2 integer parameters and returns an integer as the result. So return type is integer, the name of the function is f4, and it takes 2 integers as parameters. Here's a concrete example, example 3, that has one function, triangle 4, to print out a triangle, 4x4 triangle. As you can see, the return type is void, meaning that the function doesn't return anything. And we are making 3 calls to this function. The first time we make a call, we are going to print the first triangular pattern. The second call is going to print the same triangular pattern again. And the third call is going to print the same triangular pattern again. Let's go to that example. This is example 3. I'm just going to print a break statement in here. I would like to go step by step just so that you see how this thing works. You already know it, but it is always good to go over them again. So we are in main, trying to make a call to triangle 4. First, I'm going to do step into. So I'm going to do this F11 to go into the function. So we are inside the first statement of triangle 4. Let's execute the steps. When we reach the end, we are going to come back to main, the caller. And the next statement is again triangle 4, but this time I'm going to do F10 so that I don't have to go into the function. The function executes in its entirety. So I'm going to do F10. As you can see, we see the same pattern printed again because the function has executed in its entirety and printed out the pattern. I'm going to do another F10 just to print it out. And we've got now 3 triangular pattern, as you can see. So the first one comes from the first call. the second one comes from the second call, and the third one comes from the third for. And obviously, when we execute return 0, the program is going to terminate. Here is our second example, example 4.cpp. Again, we have a function that returns nothing, does not take any parameters, and I'm making two calls to that function. So it doesn't return anything. You're making two calls. When we make the first call, we are going to see, hi there, how are you? And when we make the second call, we are going to see the same message printed out on the screen again. This is example 4. This is the function that doesn't return anything. Again, let me just execute this so that you see that the function is called twice, and we see the message twice on the screen. Let's now look at a function that does not return anything, but takes one parameter, integer n. When I make a call to this function, I have to pass an argument that matches the type of the parameter. So this function is expecting an integer n, so I have to pass an integer, which is 573. So when I make a call, I'm passing 573. This is called an argument. This is called a parameter. All right, so when I make the call, the value of n would be 573 because this is what I am passing to the function. So I'm going to, when I run this thing, I'm going to see n is equal to 573 on the screen. When I continue and make this call, I'm passing a different argument this time. I'm passing minus 1234. So that means the value of n when I make this function call will be minus 1234. So we are going to see this message on the screen. So let's actually execute this on the example. This is example 5. So let me put a breakpoint. I would like to, I would like you to see that the parameter gets the argument, the value of the argument. So right now I'm passing 573 into the function. When I go into the function using F11, you can see that the variable, the parameter, the value of the parameter is 573 because that's what I'm passing into this function. And I'm going to execute printf to print it on the screen. So you see n is equal to 573. I come back, make another call to the same function. Now, when I go into the function, you can see that the value of the parameter is now different because it has to be what I pass into the function. And I'm going to print it and done. So that's the beauty of functions. When you define the parameters and you can pass different values of arguments into the function and get execute basically the same code using different values of parameters and achieve different things. Let's continue with our function examples. Here is a function powers that takes a parameter, double parameter x, and returns nothing. It computes x squared and x to the 6 and prints them on the screen. So x squared, and x to the 6. The first time I make the call, I am passing 1.5 as the argument. So the value of x would be 1.5, and we're going to see 1.5, the square root of 1.5, and 1.5 raised to the power of 6. The next time I make a call, I'm passing 0.11. So I'm going to see different values on the screen. This is example 6. So let's go to that example right here. I'm just going to execute this rather than going step by step so that you see what gets printed on the screen. So this is coming from the function when I pass 1.5 as the parameter, and this is coming from the same function when I pass 0.11 as the argument. Moving on to example 7. We've got a function with one parameter and no return value. And this just prints some stars n star characters on a single line, and then prints the new line to move the cursor to the beginning of the new line. So print stars, I'm making 4 calls. The first time I'm calling it, I'm passing the value of 1 as the argument. The second time, we are going to pass 2 and then 3 and then 4. So when I execute these 4 function calls, the first function is going to print 1 star, the second one is going to print 2 stars, the third one is going to print 3 stars, and the final call is going to print 4 stars. I can actually rewrite this code and put it into a for statement. So I can say for I from 1 to 4 and make a call to print stars. This is exactly the same thing. So I don't have to call print stars separately. I can call it from within a for loop like this, and it's going to do the same thing. So the first time when I is equal to 1, you're going to see one star on the screen. The second, at the second iteration of the loop, we're going to see 2 stars. At the third iteration, you're going to see 3 stars. And at the fourth iteration, you're going to see 4 stars. This is example 7. So let's go there. As you can see, first of all, I'm making 4 calls explicitly. So this is first call, this is the second call, this is the third call, and this is the fourth call. Then I'm writing the same code using a for loop. So I can actually make a call to the same function passing I as the argument. Rather than passing constant values, you can pass other variables. So whatever the value of I is, that's going to be passed into the function. So the value of n would be equal to whatever the value of n is at the time when we make the call. So let's execute this, and you're going to see we're going to see the same pattern twice. So this is coming from the 4 function calls that I had, and this is coming from the 4 function calls that I make from within the for loop. Let's now look at functions that actually return a value. So we've got a function power 6 that takes a double as the parameter and returns x to the 6. And the way to implement that is we first compute x to the 2 by saying x to the 2 is equal to x times x, and then we multiply x to 3 times to get x to the 6. The return value, as you can see, is a double. So in the main, I'm making a call to function power 6, passing 1.5 as the argument. So I should be getting 1.5 raised to the power of 6. In the second function, I have a function that computes the summation of the numbers from 1 to n. We can either use this formula. Remember, the sum of the numbers from 1 to n can be computed as n times n plus 1 over 2, or we can write a for loop to get the job done. And from within main, I'm making a call to this function. So let's go to the actual example. This is example 8. Here is power 6 to compute the 6th power of a given number. And here is sum to compute the sum of the numbers from 1 to n, including n. And I'm making 2 calls. This is power 6 and then sum 5. So let me run these functions just to see them on the screen. So power 6, 1.5 raised to the power of 6 is 11 point something. And the sum of the numbers from 1 to 5, including 5, is 15. In this example, we have a function that does not return anything, but takes 2 parameters now, integer n and character c. So it's basically running a for loop to print n many c characters on the screen. And I have 3 calls to this function from within main. In the first function call, I'm saying print 5 star characters. In the second call, I'm saying print 10 dash characters. And in the third one, I'm saying print 15 equal characters. And when we run this, we're going to see 5 star characters, 10 dash characters, and 15 equal characters. And this is example 9. So let's go there. This is example 9, as you can see. This is the function. It doesn't return anything. It takes 2 parameters. As you can see, the parameter types are different. The first one is an integer. The second one is a character. And I'm separating the parameters with a comma, which is what I have to do. And when I call this function, I have to make sure that the first argument that I pass has to be an integer. The second one has to be a character. And when I run this, you're going to see exactly the same thing that we just saw on the slides. So here it is. Those three patterns are all printed by the same function. By passing different parameters, we make it to achieve different things. So far in our programs, we have defined some functions at the top of our program and called those functions from within main. So you might get the impression that you can only make calls to functions from within main only, but that's not true. It is actually possible to call a function from anywhere within your code, including other functions. Here's an example. Assume that we want to write a function triangle integer n that prints a triangle with n rows, just like we see in here. So this has a triangle that has n rows in it. To implement this, we will implement a helper function called printRow that takes integer number of columns that prints 1 row of star characters of length number of columns. So each of these rows of the triangle will be printed by another function. So that means we'll have a main function calling triangle and triangle calling printRow. And here is that code. That's example 10. Here's my main. That's making a call to triangle 3 to print a triangle of size 3. So this first triangle of size 3 is coming from this triangle function. It's taking the number of rows, which is n. But in here, I'm basically writing a for loop to make n calls to print row function, which is another function that just prints one row of this triangle. So basically, we have main calling triangle, triangle calling. Here's example 10. I'm gonna put a breakpoint in here and go step by step. So let's make a call to triangle 3 first. I'm gonna do F11 to go inside. And in here, I'm from within triangle function, I'm making a call to print row function. So let's go into print row. And this time you're seeing that the number of columns is equal to 1. The local variable I is equal to 1. And I'm just going to print, one star character on the screen. And we will be done. We will now come back to triangle because triangle was the one that made a call to print row. This time I'm going to do F10. I'm not going to go into triangle. I'm just going to execute it so that you see row is equal to 2. That means we're going to see 2 star characters on the screen. Then row is equal to 3. I'm going to print 3 star characters on the screen. And when we return from triangle, we come back to the main function, which is where we called the triangle function. Now, when I make a call to triangle 7, the parameter value would be 7. So I'm going to make 7 calls to print row. And each time I make a call, one row of this triangle is going to be printed. After 7 iterations, we are going to be done. Then we'll come back to the main function and the program terminates. So in this lecture, you have seen what a function is in C++, the motivation behind functions, how to declare one, and how to make a call to function or invoke a function and pass parameters to functions. If you have any questions, please leave them in the comments section.